Let's give yourself a definition of power. Power is a rate. I think this ought to be your mantra. Power is a rate. Power is a rate. A rate of delivering energy. So I tried to put this up here. I don't know, maybe you can organize your page the same way. Power and energy are related. They're related by the fact that power is a rate. A watt is 1 joule of energy delivered in 1 second. Example problem 1 is a very simple circuit with a motor. I'm going to draw it schematically. And so I talked about lifting a man out of a coal mine. So we don't have horses to do that. Well, I have horses to do that. A horse could do that, but typically we use a motor, right, to lift. And a motor is what an elevator uses to lift. So how much power is this motor going to have? If this was a motor that was going to be used to lift someone up out of an elevator, how much power would be necessary? All right. So, given information, they give you in the book that this is a 6-volt battery, and the current through the circuit is 0.5 amp. And the time it takes to lift this guy is 5 minutes. Wow, he's going to be lifted a long time. It's going to take him that's a long elevator ride. They want to know what the power is. So P is our question mark. I don't know. Do we have an equation for P? Yes, that's today's lecture. Power is equal to the current times the voltage. So that ought to be easy plug-in, right? 6 volts times 0.5 amp. I don't think I need a calculator for that, do I? 6 times 0.53. What is it? 3. 3 what? Oh gosh, power is measured in watts. Okay, 3 watts. So that's not a very big motor, but it's taken in 5. Well, wait a minute. It's not a big motor because we haven't used time yet. That's just telling us how much power is being delivered to this motor. Right? We haven't really talked about how much energy is being delivered. That depends on the amount of time that the motor is running. So the second question in the example is how much energy is delivered. Right? Well, to find out how much energy is delivered, we needed to first calculate the power, which is what we just did. So the energy is equal to the power times the time. Well, that makes sense. Since power is a rate, it's going to be delivering a certain amount of energy over a period of time. If we want to know exactly how much energy is being delivered, we need to multiply the power times the time. So a power of 3 watts over 5 minutes. A minute is not a standard unit. So if we're going to use standard equations, we need to use standard units. So 5 minutes would have to be converted. So I would make a conversion factor, and I would put minutes on the bottom, because what I really want is seconds. Right? S is the abbreviation for seconds. So that would be 5 times 60, which is 5 times 6 is 30, plus another 0 is 300 seconds. So now we have the time in seconds. So 3 times 300 seconds would be 900. 3 times 3 is 9. 900. And the units for energy is joules. Capital J, because joules is a guy.